And it is my great pleasure to introduce this session's distinguished speaker, Professor Monojit Choudhury. As a leading expert in NLP, Dr. Choudhury has made significant contributions to the field of language technologies. Currently, he serves as a professor at Mohammed bin Zayed University. Prior to this role, he was a principal researcher at Microsoft Research and later principal applied scientist in Microsoft Turing. In addition to his academic and industrial roles, he is also part of IIIT Hyderabad as an adjunct faculty and also as a professor of practice at Plaksha University. Professor Choudhury is also deeply involved in academic community as the journal chair of Padani Linguistics Olympiad and founding co-chair of the Asia Pacific Linguistic Olympiad. Beyond these professional achievements, he has passion for popularizing linguistics and NLP among school children and non-practicing individuals by designing engaging puzzles. We are truly fortunate to have him here today. And without further ado, let's listen to his very interesting talk. Please join me in welcoming Professor Monojit Choudhury.
Thank you. So good afternoon, everybody. First of all, a big congratulations to LTRC for the Silver Jubilee. And I really feel honored to be here today speaking at and taking part in the Silver Jubilee celebrations because, LTRC played a very defining role in people from my generation who started and did NLP in India. And of course, the tradition has continued, and even in today's people who are doing NLP today from India, LTRC has a big role there as well. For instance, my PhD students, some of my research associates, collaborators did their undergrads from LTRC or masters there in LTRC. So initially, I thought of talking about how generative AI, linguistics, Indian language NLP has been interacting. But then there is a panel tomorrow on linguistics, which is very exciting. I'm part of it. So I will keep all the thoughts about linguistics for that panel. And then I know that we had a lot of very good discussion on LTRC's journey, which Deepti narrated in the morning, and then about the state of things, which Srinivas talked about. So it's very hard to add something to that story. But I will still tell you the same story, but put in a different way from my personal lens. So let's begin. So this is my first paper, and also first paper in NLP. It was published in 2002 in KBCS. And ICON happened to be co-located with KBCS that year. And this was the first ICON, So it's a very special thing that I always cherish. The title of the paper is a rule-based schwa deletion algorithm for Hindi. So you can see rule-based in the title itself. So those were different days. But the other interesting thing I thought, like when I was reading through the abstract, again, after some, 20 years, I saw it says the accuracy was 96% of the algorithm on the commonly used Hindi words. And inside the paper, like the commonly used Hindi words were like 10,000 words from the dictionary. And I personally evaluated actually for those 10,000 words because there was no existing data set on which you could readily evaluate, things like schwa deletion. So, and the other thing I remember from this particular ICON was there was a talk by Professor Subbarao, and it was on linguistics typology. And that was the first time I was introduced to, I did computer science, so had no idea of linguistics. With schwa deletion, I started looking at phonology a little bit, but I had no idea about syntax and typology and all that. So it was very, very inspiring, and it stayed with me for a long time. Still, it's there with me. The other thing which really inspired me, and I still have a copy of this book. I thought of bringing it and getting it signed by the authors because they are here today. But unfortunately, I forgot. So what I really loved about this book is there are many books on NLP, right? But this book connects something very, very ancient, Panini's Ashtadhyayan concept from there with something which was very, very state of the art at that point of time. And we will see how we can do more of this kind of things in today's, NLP world. And this will be broadly my goal for this talk. But I will tell you more of it like a story, like I started, and from a very personal lens. So yeah, so those were the days, and it wasn't very easy. There were lots of different kinds of challenges. The GPUs were not the challenges at that time, but we had other kinds of challenges. What? So some of you might even think, not, people who joined NLP 5 years ago or even 10 years ago won't even imagine that one of the biggest challenge was there was no unified representation of index script. So if a Hindi newspaper displayed it in a certain font, most of the computers, it will not show it unless you specifically downloaded the font and installed it, right? So what the newspapers did, or people who created Indian language content, used to put images. And there was a lot of work, and some from LTRC at that point, to come up with notations and unified representations for Indian languages, like WX notation. And there were alternatives like ISKI from, I think, SIDAC, iTrans from somebody. And how LTRC played a very pivotal role, for instance, even here, was there were these plugins which could translate between these different encodings, which I used a lot during my PhD. I would now, because different data sets will be in different formats and all that, and we use those. So this 2000 to 2008, which I call the first era of my journey in NLP, and also LTRCs, because we started pretty much around the same time. So it was about getting the foundations right for Indian languages. The other foundation that we had to get right was annotation standards. LTRC played a tremendous role in getting that, and there was a huge collective effort. I'm not getting into those details. You know this very well. Getting data sets was a problem. And again, we are not talking of the same scale as today. So data sets were like 5,000 sentences annotated, right? But even that was challenging, getting that kind of data set. The only Indian language corpus at that time was from, I think, CIIL, and it would come in a CD. You would have to buy, pay, and get the CD from them, and then use it, and so on and so forth, right? And the last point, which is very, when you think of it, it's very interesting. It was extremely difficult to attract talent in NLP at that point of time. NLP was not the cool field. So I wanted to do my PhD in theoretical computer science, because theoretical computer science was the, holy grail for computer scientists in India at that point of time. In linguistics, people wanted to do in theoretical linguistics, work in theoretical linguistics. And so neither linguists nor computer scientists were interested in computational linguistics or NLP. Like of course, today it's a very different story. So just last couple of weeks ago, I was at TMNLP moderating a panel about where is NLP today and where it is going. And I mentioned this, that at that point of time, like even 5 years ago, and definitely 10 years ago, I knew each and every Indian origin person in the field, who used to do NLP and speech personally. And today I don't even know maybe 2% of them. So it's a great thing that the community has evolved, and there is a lot of excitement. So different era, different challenges. Let me wrap this era up with this story. This is a presentation from IJC NLP 2008, which incidentally was also hosted by LTRC in Hyderabad. And I gave this talk at that IJC NLP. I picked that slide. I mean, I'm very bad at keeping photographs, so I couldn't find any photographs of people. Our LTRC fun meetings and all that we had. But I keep the slides because they are very useful. So this was exactly the slide and the talk title that I presented. But the question I was asking was, by 2008, right? And even in 2002, machine learning algorithms were all there. So if you think of SVMs, decision trees, and random forests, and all the sophisticated classical machine learning algorithms, they were all there. Deep learning was also there, only for academic purposes or educational purposes. Nobody used it. But transformers were probably the only innovation mainly that happened after that. So in terms of technical innovation, a lot of these things were already there. The only thing was there was no data, not enough data. So again, it was data-driven NLP by 2008 pretty much. And I tried to look at how much data different languages had. And one place to look at, so by the way, in that era, the only data that mattered was annotated data, because the learning algorithms were good at only supervised learning. There was no, large-scale, great unsupervised learning algorithms, especially in text. There were algorithms, but they didn't work very well. So what I plot in this graph is, here is the number of items, resource items in LDC catalog. And here is the, rank like by language. So this language, no prize for guessing which, it had some more than, it has close to 300 items. This was English for sure. And then it dropped very quickly, because note that this is a logarithmic scale. So it's a log-log plot. So it's a very, very skewed distribution, right? And this one is same thing, but in terms of millions of words rather than in terms of number of items. And 4 languages stood out: English, Chinese, Arabic, Spanish, and Arabic. And I used to make the joke that the only language we create resources are either spoken in the US or feared by the US, right? So those were the 4 languages where people created resources. Indian languages, I think Hindi will be somewhere here, and Bengali will be here. Other languages didn't even were there. No, nothing at all. The other interesting fact was, so these were the paper distribution, like languages which the papers worked on, published in Proceedings of IJC NLP. And of course, English was the highest. So the Indian languages, you can see Hindi here, and it was in India, so probably we had more Hindi papers than usual. And then probably one paper each in Telugu, Sanskrit, and Bengali. But the interesting thing is, so blue means the paper title was mentioned, the language name was mentioned in the paper title. Red means in the abstract, not in the title, but in the abstract. And green means, or yellow means, neither in these two, only in the body. And you see, most of the English don't even mention it, right? So this was the era of, rise of English as the universal language. So if you do not do it for English, it's not useful. If you do it for English, it's assumed that it works for every language. It took a lot of effort by a lot of people to change this. And it would eventually lead to what is called now the Bender rule. So in 2019, Professor Emily Bender in ACL went to there was a presentation, and she asked, which language are you working on? You did not tell it in the presentation. And now it is known as the Bender rule. You have to mention the name of the language in the title of the paper which you work on. If it's a lot of languages, then probably it's a different story. Or in other words, English is not the universal language. So then the natural question, which at the end of this era, people like me were asking, is, can you make an international career in NLP by working only on Indian languages? It's a very crucial question. And my mentor at Microsoft Research, I was at Microsoft Research, just finished my PhD in 2007. So around the end of my postdoc, beginning new career, right, in the field, strongly advised not to work on Indian language NLP. The idea was, you work on NLP, but other languages, because the moment people brand you as Indian language, you don't have an international career. So what happens next, right? So one thing that we all as a community invented, and I will again say LTRC has a very big role to play there, is what I would call local inspirations and global aspirations. And this is the era, the second era from 2010 to 2018. What happened here is, well, India is a very, very rich country in terms of languages, multilinguality, very complex social structures and political structures and so on. And this all have a very strong impact on how languages work, right? And how technologies need to be deployed. So we found out very interesting problems which were relevant for India, but then we tried to apply it at a global scale. And that gave some foundational breakthroughs from India, which I will talk about. I mean, since it's a personal journey that I'm recounting along LTRC, so I will talk of one which both me and LTRC worked on, which is code mixing. So Code mixing or code switching was not in the NLP map at all back in 2008. Nobody talked about it. Nobody worked on it. And by 2018, every company worked on code switching. When in EMNLP we gave a tutorial in 2019 on code switching, the hall was full, like 200 people, and 100 of them were from industry. And in India, it's an obvious thing, right? People code mix. Without code mixing, we can't even talk. But we had to do a lot of, statistics, crunch a lot of statistics to show people that people code mix all over the world. It's not an India-specific phenomenon. So that's the global aspiration part of it, right? We started from observing it in India, showed that it works, it happens everywhere, and came up with foundational solutions that now is, till 2018 has been very, very useful. What happens after 2018 will come to that. There are many other such stories. Another area where I think Indian NLP has contributed a lot to the global scheme of things is transliteration. We had very foundational technology that came in this area from India. And of course, NLP for extremely low resource languages, which is also very relevant for India. So of course, all the things in the first era, right, was going on. Data creation of annotation standards, everything was going on. Along the side, I would like to say that these are some of the things where India kind of influenced the world of NLP. And since we are talking of LTRC, I have to show you this. So when I started working on code switching, we were looking at some of the linguistic theories of code switching so that we can generate synthetic data to train models. And one of the very foundational work there is by Professor Arvind Joshi, which is called the matrix embedding theory of code mixing. This is one of the 2 or 3 very well established or competing theories. I think Professor Joshi came up with this in 1982. And again, thanks to LTRC, of course, Professor Joshi was very strongly connected to LTRC, but they also gave me the opportunity as a student and later as a young researcher to interact with Professor Joshi because he would come to almost every icon. And I could talk about his theory to himself, right? And how inspiring it can be, if you think of it, right? This is like, he is one of the father figure in cognitive science, not only Indian language NLP, just overall cognitive science. Okay. So then the story changes here dramatically in 2018. What happens is BERT comes, and 2018, 2019, and I call it the end of an era. Why? So I'll just, you all know this, but from my personal, like when I felt I took the hit myself was, so you don't have to look at the numbers, but these are like the best state of the art that we achieved in a bunch of tasks for code mixing across 2 pairs of languages, using a lot of this theoretical work that I said. And it's 8 to 10 years of research by a lot of people. Not only like us at Microsoft Research, whose research I'm representing here, but a lot of people from LTRC, from other places, and so on. And based on all that, this was the state of the art. And MBERT, multilingual BERT came, and it bid statistically significantly on every task, every language pair, without doing anything further, just off the shelf. So then it was like, oh, all the expertise, all the work that we did all through these years is now useless. Like these models can just do it all. Is it really the case? What to do? How to invent new problems? So it started a different era altogether. And you all know this era because we are living in this era right now, which is, let's call it for the time being era of LLMs. I'll give it a different name in a moment. So to us, at least, NLP researchers, in text especially, 2018 was when we knew that the change is happening. For the rest of the world, it was 2023 when ChatGPT came, when people realized that something big is happening. Of course, in India, we were not behind, right? We did a lot of work. We are still doing a lot of work. There is a lot of projects that's happening in this broad space of building Indian language specific LLMs and so on. In fact, we ourselves built a model called Nanda. Recently, we released it. It's a 10 billion parameter model trained on top of Llama for Hindi, and it's the best open source model in that weight range category for Hindi. So a lot of such work is going on. But then the problem is this research? What kind of research question are we asking and answering? That's a big question to me and a lot of people, right? In research, always have a research question. What is the research question here? Of course, we are building artifacts for sure, but what is the research question here? And then what I see is there is a lot of, existential crisis, so to say, amongst everybody. So academia thinks industry has all the resources, all the GPUs, they are doing all the things. What can we invent in academia? We are lagging behind. If you ask the industry people, and I have been in industry, I was part of the Bing Copilot team, like when with GPT-4 we built the Copilot, I was in the Turing team. And industry has the same problem. Only a select few people have GPT-4. Microsoft is always worrying, Google is doing the thing, Google is worrying, OpenAI is doing the thing, and so on. So actually, I will tell you, nobody has a clue what's happening, right? Everybody is just very, very confused and struggling. So I call it the era of great identity crisis that NLP is going through. I hope it will change soon. And I have strong opinions on why, academics at least shouldn't bother. That's why I decided to switch from industry to academia. And I don't bother. I don't have this crisis. But that's my personal opinion. So this is what is happening. But now the question is, like, have we really solved the problems that I pointed out from the last two era? So I took the title of my talk just yesterday, asked Chat GPT to translate it to 22 Indian languages. And this is what it gave. Quite impressive, right? Like, first of all, it listed the 22 Indian languages in the order of the population. It didn't say it, but I could figure that out. And then I could read some of them like Hindi, Bengali, and they were pretty accurate. But not everything is solved. You see, Manipuri is still that encoding problem I talked about long back, like 2000s, early 2000s, still there for some languages. And of course, you will see a lot of English characters thrown here and there. So transliteration is still a problem, right? So those problems still exist. And I don't read all these languages, understand. I'm sure there will be many problems with syntax and other fluency with, as you go down lower in the list. But it's a great progress, undoubtedly. So there's a scope to improve, but it's a great progress. Now, what fuels this progress, right? So to answer this question, in 2019, we asked the same question that I asked in 2008 during the IJC NLP talk. How much resources does world's languages have? And how does it, kind of influence what you can do in a language or you cannot do in a language? But now the situation is really slightly different. How the situation is different is, of course, label data is important. Like, so this axis plots label data. And again, I think these are also LDC counts. Whereas this axis now plots unlabeled data. Because unlabeled data becomes extremely important for our pre-training model. The more the unlabeled data, the better the language models are, right? And one of the reasons we can do so well for so many languages today is because even though they may not have labeled data, they have a lot of unlabeled data. So we have things like cross-lingual transfer happening and so on. But then what happens here? I'm not sure if it is very nicely visible, but each dot is a language, right? And no prize for guessing that this is English. Again, it's a log-log plot, so one grid below means one order of magnitude less. And in this work, which was in ACL 2020, so we kind of divided clustered roughly the languages into groups. And we called them class 5 to class 0. The class 0 is this one. Most of the points are in origin, so you can't even see them. Now, 5 is, of course, they have all the resources and everything. They are doing great. 4 are the languages which are also doing good. I mean, rather great. 3 is the one which we called out as rising stars because they have very little labeled data. So using previous technologies, you couldn't do anything for them. But with a lot of pre-trained data, lot of unlabeled data now for these languages, they started, the model started doing great for them. So these were the rising stars, and there were 28 languages with 1.8 billion speakers there. So we are doing really good here. But what about 0 or even 1 or 2? It so turns out that deep learning technologies really don't cater to these languages. On top of it, it actually is amplifying the gap. Because earlier, we used machine learning, like classical learning for these languages, maybe rule-based for these languages, and the gap was not so much. With deep learning, you are doing far better for these languages and far worse. So more and more, technologies now online will be there for these languages, and people will be pushed to move from speaking these languages to those because of opportunities. And that's a big, threat to, or it endangers the existence of many languages. So technology has amplified the gap. To summarize, 88% of the world's languages, right, spoken by 1.2 billion people are totally untouched by any of the technologies that we are building. These are the classes. I will not go through them, but I will just mention that the only Indian language in class, there is no Indian language in class 5. Hindi is in class 4. I think Bengali, Tamil, and few other languages, 4 or 5 languages are in class 3, and everything else is 2, 1, or 0. And Santhali, I'm only talking of the scheduled, 22 scheduled languages, right? And Santhali and all are in 0. This was 2020 when we did the study. Okay, now the fun thing is, because of Bender rule and all this noise about low resource languages, eventually low resource became a fashionable statement. So now everybody calls whatever they work, it is just the reverse thing. They will, like LLM is a fashionable statement, maybe no longer, right? Now everybody works on LLM, it's too cliche. But low resource is still in academia very fashionable. So recently in 2024 EMNLP, we asked another question, right? When people say low resource, what do they mean? And this is also interesting. So first, let me show you this graph, which shows that we looked at recent papers, around 160 papers, where people mention low resource languages. And the second most mention goes to Hindi. Is Hindi a low resource language? And I argued it's in class 4. So I think it's a relative thing. Compared to English, Hindi is definitely low resource, or compared to Chinese, Hindi is low resource. But yeah, I personally would not call Hindi. But it's good that there are a lot of Indian languages in this list, right? There is Telugu, there is Bengali, there is Marathi and Tamil, and so on. And the other interesting thing is, if you remember the IJC NLP graph, there African languages were completely missing. Now a lot of African languages have come, right? So a lot of work is going on in African languages. And they, as I shall argue in the next slide, use India as a model for building technology, building low resource language technology and all that. So yeah, so the point is that language is a very complex thing, right? So when you talk of how much resource a language has, we can talk of data, but data is not the only thing. Data, technology, linguistic knowledge is one part of it. But there are also questions of human resources, access to digital devices and all that. And also there are socioeconomic factors. For instance, a language might have a lot of all the other things, but is not used for education. So that's a political choice. And because of that, the language might have other kinds of problems, right? Lack of investment and so on. So it's a complex thing, and we try to analyze how much the other factors get attention to. And as you see in this graph, not much, right? So most of the red blocks here is data. So most is data, and other things are hardly talked about. So that's one more point we wanted to bring in this paper. And the last point I want to mention is agency is very important. We always think, okay, we make language technology, people's life will be great who speak those language. Not at all, right? What I want to do with my language is completely my choice. And there's a lot of documented records from, especially from Aboriginal Australian languages by Stephen Bird, which says, people just don't want to give their data or make their data digitized, because that's like for them killing the spirit of the language. In short, the agency should be always with the speaker, what you want to do. So it's not a very binary thing. It's a very complex thing which one needs to understand and navigate when one talks of technology for languages. And this is what I want to highlight from this slide. Okay, so where are we now, right, with all this? So we see that it's an identity crisis and all that going on, but we are doing better. Maybe an overarching goal for us would be to get all the languages at par in technology with English, it's a moonshot. It's probably never going to happen, but we can have that goal. But I think that's definitely an important goal, but that's not necessarily a research goal in my opinion. The question I would like to ask and all of you to think about is, what do India and Indian languages can offer to the field of NLP? Because somebody invents transformer, somebody invents this code, puts it on Hugging Face, we take it, we train a model. That's fine, but can we do something more than that in terms of research? And of course, there are many things that can be done. I will just quickly tell you 3 things that I think are very interesting, which India can contribute to the world of NLP. And this is a great example, right? So of this kind of work. So the first is, I would say, India can give an innovative model of co-creation of data and technology at scale for the global south. Because the amount of language diversity and the number of speakers per language is nowhere as much as in India. And therefore, we have the market. It's not that people don't have purchasing power and all that, right? But scaling it up to that level is an extremely hard problem. And we have to come up with very innovative models for that. And so a lot of work is going on in that direction, but I think those are the models that we can provide. And like I said, for instance, the whole continent of Africa with thousands of languages, which are all in class 0 or 1, except for Swahili maybe, they are following some of the models that we develop in the Indian context. So this is where a lot of research can go on. The other thing is, India is also very interesting in terms of linguistic aspects of the diversity, right? We have languages from 5 or more language families. There are languages which are very close to each other, like Hindi and Urdu are essentially the same language. Or we have languages like Bangla and Odia, which are very close to each other, but languages which are also very far, right? Let's say Khasi, which is an Austronesian language, to Tamil, which is a Dravidian language, are very far. Now, if you want to work with all these languages, you have to come up with very smart models of cross-lingual transfer. And frankly speaking, we observe the phenomenon, but we don't know how cross-lingual transfer happens. This is going back to Srinivas's point about white box, black box, right? It's a black box, right? We don't know. So we can contribute a lot, because I think we are the people who will be most interested and influenced by such technology. So this could be great research question. And the third point I want to say, and this is what I'm working on right now, is at the intersection of culture and technology. Because it's one thing to support a language linguistically. Like a model might know how to translate from English to Hindi, but it may not know the cultural context in which the translation is to be used. And then the translation can totally go wrong. It can be totally useless. So with LLMs kind of penetrating every sphere of life, right? It has to be very culturally appropriate. And there are a lot of work that shows that how LLMs today are very strongly culturally biased towards the West. We are just scratching the surface. There is a lot of interesting questions here at theoretical level, like what is expected from a technology when you say it has to serve the users from a culture? What is expected at the model level from an LLM and so on? And there are also interesting computational social science questions here, that how LLMs can, or generative AI can help build social science theory. And I think there is a lot of interesting things that can be done there as well. In the interest of time, I will not get into the work, but I'm doing some of these, I'm trying to ask some of these questions. If you're interested, I'm here, so I'll be more than happy to talk. So with those 3 broad ideas, let me wrap my talk thanking LTRC again for not only setting up the foundations for Indian language NLP, but also these lessons of thinking locally and dreaming big and globally. And also a personal thanks for conducting the Panini Linguistics Olympiad, which we had started back in 2013, 2009, 13, around that time. But since 2016, LTRC has been driving it amazingly successfully. Yeah, and congratulations again for the Silver Jubilee. Thank you.